Okay, 8.3, trig integrals, trigonometric integrals. Yes?
Hi, Natalie.
Okay, integrals involving powers of sine and cosine, such as m to the s to the m, s, how about sine to the m, cosine to the n, secant and tangent. We can use these rules. Some things to remember is you need to remember the Pythagorean identity, that sine squared x plus cosine squared x equals 1. You also have, well, they're called power reducing formulas. Also, they call them, in the earlier version of the book, they called them half angles, but they use them for power reducing. So sine squared is equal to 1 minus cosine of, and this 2x is the cosine of 2x. And cosine squared is the same, but is plus. So 1 plus cosine of 2x over 2. They will come in handy when we're trying to manipulate things. They're power reducing. That's what they call them in this version of the book. And that's what they're used for, to reduce the powers. Are you good? Yeah. Okay. So, some rules to remember. If the power of sine is odd, so that's if the power of sine is positive and odd, you might want to use this method. You save one sine factor and convert the remaining factors of cosine factors to cosine, sorry. So if I had like sine of, it's 2k plus 1, that means just any odd number, times cosine, you'd pull out that sine and leave it, and then convert whatever you have left into cosine. And this used the Pythagorean identity, because 1 minus cosine squared is sine squared. Likewise, if the cosine is odd and positive, the power of it, you pull out a cosine and convert the remaining factors to sine. And then you can use that again with that Pythagorean identity. If the powers of both sine and cosine are even and non-negative, you might want to replace them with one of the power reducing formulas from before. And then you go on to one of the other ones.
What did they say positive up there and non-negative down there?
I don't know. Because non-negative would include 0, I guess, but then it wouldn't be a power. I don't know. Because positive numbers are 1 on, non-negative includes 0. So I don't know why they would say non-negative. Okay, so the first one we have find the integral of sine cubed x and cosine to the 4th x. Now, as I do these, I will use more steps than they do in the textbook, just because I think it's necessary to see more when you're learning how to do them. Okay, so we got these powers. We've got sine and cosine together. We have an odd sine.
Yeah.
So it said pull one out and convert the rest. So basically what you do is you just rewrite it, and you have sine of x times sine squared of x cosine to the 4th of x. So we're now going to convert the sine squared into cosine, and I'm going to put that in the front. You can put it in the front or the back, but don't leave it in the middle of two other things. Okay. So I have 1 minus cosine squared times sine of x cosine to the fourth of x. So at this point, I have to distribute the sine cosine into. No, I don't have to distribute that. No, I'm only going to distribute not both of it. Sorry. No, I am. I'm going to distribute all into it. Sorry. Can't make up my mind. So when I do that, I'm going to have two terms separated by that negative, so I can take the integral of each term individually. And I'm not going to have any room to go there because I'm going to go farther. So I have the integral of sine cosine to the fourth dx minus the integral of sine cosine to the sixth. You okay with that? Okay, so now that I have that, we're going to use the cosine as our u, because remember that's cosine of x to the fourth, yes? And to the sixth. So u is going to be cosine of x, and u prime, or du, will be negative sine of x. And since I have that negative sine of x, all I have to add in is, I don't have the negative, I have the sine, I just have to add in the negative. So I now have negative the integral of u to the fourth du. And likewise on the second chunk, it would be not negative anymore, but plus the integral of u to the sixth du. So I get negative 1/5 of cosine to the fifth plus 1/7 cosine to the seventh plus c. So after you make that initial decision whether to keep something back or put whatever you're keeping back, it's pretty much what we've done before. Questions? Tom? Okay, so it's a definite integral this time. Hate plugging things in just because it's trig problems, right? So hopefully you're writing this sine to the 1/2, correct? So that the integral from pi over 6 to pi over 3 of cosine cubed over the square root of sine of x dx. So which one has an odd power?
Cosine.
Cosine. So the rule says pull one back and convert, right? So I have the integral of the cosine times the cosine squared. I'll do it one more time, all the steps, but after that I start skipping. I know you guys probably want to. Now I can put that 1/2 next to the sine now, because it's just a power. So cosine squared is 1 minus sine squared.
I think so.
And I'm going to bring the sine to the 1/2 up, because I don't want it down at the bottom anymore. So I have cosine. Can I just write cosine, sine? Do you guys need the x's? You good? Okay, sine to the negative 1/2 times 1 minus sine squared. So then what do I do? Distribute.
And then write it as two different equals.
So I have cosine sine to the 1/2 dx minus,
The negative
yes, to the negative 1/2 minus cosine sine to the, well, it's 4/2, so 3/2 dx. And so then what is u?
Sine.
And u prime?
Cosine.
So we have our cosine, so we're good there. So I have the integral of u to the negative 1/2 du minus u to the 3/2 du. So what? 2 sine to the 1/2 of x minus, add 1 would be 5, so 2/5 sine to the 5/2
Of x plus c.
Mm.
Oh.
Good try. And then you would plug that in, right?
I don't know if I would. I'd probably just put plus c.
You're probably like, I'm done.
Because it's not even like.
Well, it's going to be 2. So the sine of pi over 6 is 1/2, right? Wait, b minus a. Yes, b minus a. So then I have the square root of 3 over 2 to the 1/2
Yeah.
minus 2/5 the square root of 2 over 2 to the 5/2 minus 2 1/2 to the 1/2 plus, because you have to distribute your negative, right?
Yeah. Plus
2/5 1/2 to the 5/2, and you would have to stick that in a calculator.
Shouldn't that square root of 2 be square root of 3?
Oh, and the second one?
Yeah.
Yes, should be. And you put that on your calculator.
You can't do this in your head.
I don't want to do that in my head.
What kind of math you should
Okay, well, if I do the square root of the square root, so I have the 4th root of 3
Yep.
over the square root of 2,
Yep.
which gives me the square root of 2. Okay, so that's the first part. Because of the 2 I'd rationalize and the 2's would reduce. And then I need the square root, so I need the 5th root, so that's 3 square root of 3. And so I need 5, 2, 4, so that's 4, but that's the 4th root. You're torturing me.
You don't have to finish.
4, the square root of 2 all over 5. That's horrible.
Well, we can stop now.
Okay. You wouldn't know if I was doing it wrong or not. Okay. The integral of the cosine to the 4th of x.
This is really loud today.
What's our problem?
We don't have a sign.
And I don't have an odd power, do I?
No.
So should I probably use one of those reducing? Yep.
Ah.
So it's 1 plus cosine over 2, right? Squared? Not squared.
Cosine's 2x over 2 squared. Because we have 2.
So 1 plus the cosine of 2x over 2. I forgot my 2x. Okay. So we're going to see this as cosine squared and cosine squared, right?
Yeah.
So we have the integral of 1 plus cosine of 2x all over 2 squared. Okay, this is where the book and I part ways on how we do this problem. I am a big one for factoring out those coefficients. The book, I've even had math instructors where we're doing multiple integrals and they still don't, and I don't understand why. They deal with these gross fractions. When I square 1/2, I get 1/4, correct?
When you square 1/2, you get 1.
Because this is 1/2 right there.
Yeah.
So I'm taking that out. So now I need to square my numerators. So my rule for when I square binomial is what? The first one squared plus 2 times the 2 multiplied together. And the last one squared. So cosine squared of 2x. So I didn't separate those, but I would hope you know that we're going to do the integral of all of them individually. Yes? Do I need to write that out?
Right out what?
Like the integral in between each one?
It's just a waste of digital mark.
Okay. Well, it's a waste of my space, and it's pretty... Okay, so I got 1/4, right?
I think.
And then I bet we just have x.
And I bet, yeah. See, I don't really.
And see, on the other two, our u is going to be 2x, isn't it? And then our u prime is going to be 2.
Well, that's the end.
Okay, so
So it's just cosine to that, right? Or the sine.
well, it would be 2. Because you have to bring out the 2. My brain is like, I know what it is. The answer is cosine of 2x. I mean, sine of 2x. But are you guys good with leaping there?
Sure.
Okay. It's sine of 2x because we'd have to have a 1/2 in there, correct?
Yeah.
Okay. So we have the sine of 2x. I just didn't want to lose anybody. And then we have a problem here.
So, yeah, exactly what we started with.
we still have the cosine squared, correct? So we probably should put it back into this. But this right here was the cosine of x squared, yes? And we aren't x, we are what? 2x. So this 2x has to be multiplied by 2. By 2. Everyone follow him?
Yeah.
So I'm going to bring out my 1/2 again. So I'm going to have 1/2 the integral of 1 plus the cosine of 4x. Does that make sense what happened? Okay, so then I have 1/4 x plus sine of 2x plus 1/2 x plus, wouldn't it be 1/4 the sine of 4x? Plus c. So now we need to make it a little prettier, don't we?
I like it. I think it's beautiful.
Well, we have 2 x's. You can't do that. We got to simplify. So this is going to be 1/2 of x. And this is going to be 1/8. And so I have 1/2 and a whole. So I have 3/2. Do you want to leave? I'm going to leave that 1/4 out there.
There's no reason to make it messier by including.
So I have 3/2 x. And I have sine of 2x. And I have an 1/8 of sine of 4x. And I still don't like how it looks. I would personally factor the 1/8 out. Because I think it's gross.
I don't.
I think about it like if I had to plug something in, if I had to do a definite integral, I don't want to be dealing with 3/2 and 1/8. That's me, myself.
Doing a definite interval.
Until I tell you we're doing it. So do you guys want to leave the 1/8 or factor it out? Okay.
Whatever makes you happiest as well.
I want to factor out. Because I have 1/4 factored out, why would I leave other fractions in it? Okay, so I'm going to factor out a 1/8. So I get 1/32. So that means I multiply by 8. So 2 goes into 8 4 times, so I get 12x. Plus 8 sine of 2x. Plus sine of 4x. Doesn't that look prettier? It looks like I wouldn't complain too bad if I had to plug a number in. To me.
I still don't know.
You would still complain? Okay. So ready for some secant tangent fun then?
Class is almost done.
Is it?
No, but my paper's almost done.
I think one example will be fine.
Okay. Let's get cracking.
So we have a bunch of these rules again.
Yeah.
So if the secant, but these are different because it's not odd, it's even. So if the secant is even positive, yeah. Okay, so if you have an secant that's even positive, you save a secant squared factor and convert the remaining factors into tangent. Okay. What?
So then expand.
Then expand and integrate. If the tangent is odd, positive, save a secant factor and convert the remaining factors into secants. And the reason for that is when you do your U's, secant squared would be the one, and secant squared is the derivative of tangent, correct? And secant tangent is the derivative of secant. If there are no secant tangents, if there are no secant factors and the power of tangent is even positive, so even positive, no secants, convert the tangent squared factor into secant squared, then expand and repeat as necessary. So this might be something that you have to keep doing to get it to work. Okay. So again, that's on page 539. So the integral of the tangent cubed over secant of x. So I'm immediately going to write it as the integral of tangent cubed secant to the 1/2, negative 1/2. So my rule said if it was odd, what should I do? If tangent was odd, what should I do?
If tangent is odd, I don't know.
Factor out a tangent
Okay.
and convert the other tangent into secant. So I'm going to write what that would look like because it's going to look different. Did it say that?
That is a good question.
No, I want the exact words because
Why does your C look more like an E than your E does?
I don't know. Okay, if the tangent is odd, positive, which it is, save a secant tangent factor. Okay, that's what. Okay, so
How do we save one?
yeah, because that's what I was like. So to save one, that means to factor it out. Yes, like to move it over. So how we're going to do that is we're going to have tangent squared when we factor out a tangent. Yes. What is factoring? Factoring is division. So if I'm going to divide and I have exponents, I subtract exponents. Yes. So if I'm going to factor out, I'll write my secant so I'm going to have tangent. And then I want to factor out a whole secant. So that means I have to subtract 1 from negative 1/2, so I get negative 3 over 2. You didn't know you could factor out what you didn't have, did you? It's kind of gross. But is it legal?
I guess.
It's legal. Okay.
I don't know how far you can go negative.
It's legal. So now we need to convert this tangent squared into secant squared. So the Pythagorean identity, it should have said remember all Pythagorean identities. So do you guys remember the tangent one?
Tangent squared equals 1
Plus.
secant, 1 plus tangent squared, so it'll be secant squared minus 1.
So 1 plus tangent squared is secant squared, 1 plus cotangent squared is cosecant squared. Okay, so it's going to be the integral of secant squared minus 1.
Yeah.
Can I just write ditto marks for everything else?
You could.
Because we're going to do what with it? We're going to distribute it through, aren't we?
Uh-huh.
Okay. So now we're going to take this mass and distribute it through this. Now do not be tempted to put the two secants back together, because we are always tempted to make it smaller.
Let's just think of it.
So I now have, you want your tangent first? Probably not. Okay, so I have secant to the negative 3/2 times secant squared gives me secant to the half. Tangent secant. Minus the integral of secant to the negative 3/2 tangent secant. My tangents get really sloppy. I wrote DD on my paper instead of DX. Okay, so what is U going to be?
U is going to be.
It's going to be secant because the derivative of secant is that tangent secant combination. So derivative is secant tangent. So that gives me the integral of u to the 1/2 du minus u, the integral of u to the negative 3/2 du. So 1/2 plus 1 is 3/2, so 2/3 secant to the 3/2 plus, yes, because it's still going to be, so add 1 would be negative 1/2, so 2 secant to the negative 1/2 plus C. Isn't that fun?
No. I didn't even do it.
I don't think it's fun either.
Who decided that all these little 3-letter combinations have all these properties? Because they should have not.
So when you're doing these, I do not think it would be bad for all three of you to get together and just do them.
Well, you can't do that, so in high school.
You can't do it here, but you can do it. We're going to do today, and we're not going to do anything past today. So you have every other odd. I had more practice on it on Monday, but I think we'll just start the review on Monday. So Monday, Tuesday review, test Wednesday, and then start reviewing for your final. And I have your final on the 26th and 27th because you have track on the 25th.
Yeah.
Is that right? Or do you want us to, or do we want to do the 27th, 28th?
I have track on the Monday.
On the Monday.
Yeah,
Okay.
it's different from the school calendar.
On the Monday too. Well, on Wednesday, you guys have your interview times. So
We could try to arrange to not be during this.
right. Well, what I was going to say is if we need to, we can move back to the 27th, 28th,
Yeah.
unless you guys were planning on your trip. So,
It was really, the trip's kind of dead at this moment,
At this point, we should just not.
okay. Well,
honestly.
track is the Monday, so we're good for the rest of the week. Let me know. I know I don't want the final starting on Tuesday.
Okay.
So, I don't think you want it starting on Tuesday either. That would give you some time in class. And remember, the final is only what was on last semester's final. And then what we've done.
This-
And you guys will have derivative integral sheets. You will also be able to have a note card. I haven't decided what size of note card for any other information you'd want on there. I do...
A 9 by 11 and a half.
I do sway you from putting too much information because
You just can't.
you can't find it and you spend more time looking for it. So be conscientious about what you put on that. Questions? Come.